There is a specific kind of failure that is worse than ordinary failure. It's the kind where everything looks correct, where every instrument reads normal, where the technicians go home on time, the shift logs show no anomalies, and the supervisors sign off without a second thought, and the whole time something is dying. In the spring of 2009, a man we'll call Reza drove to work the same way he always did. He passed the same checkpoints, showed the same credentials, nodded at the same guards. He was known here. He had been coming to this facility or to facilities like it for years. He was a technician, a specialist in industrial control systems, reliable, unremarkable, trusted. What was inside his jacket pocket that morning was none of those things. Reza didn't build what he was carrying. He didn't fully understand it. What he had been told by people he had learned not to ask too many questions about was that the device would collect data, that it would map the network, that it was a surveillance tool, a passive one. He had been told not to worry. He believed them. He needed to believe them. Because if what was actually on that drive had been explained to him in full, it is not clear he would have walked through those gates. The Natanz uranium enrichment facility sits beneath a plateau in Isfahan province, central Iran. Above ground, it looks like almost nothing. A cluster of administrative buildings, a water tower, a perimeter fence. It is the kind of place that was designed to look like it doesn't matter. Below the surface is a different structure entirely. Hardened concrete bunkers, 20 feet thick, buried under another 20 feet of earth. Anti-aircraft batteries positioned at multiple angles. An internal security apparatus that monitors access at every level, physical, electronic, human. And inside those bunkers, in long underground halls, row after row after row of centrifuges. Thousands of them. A centrifuge, in the context of uranium enrichment, is a machine of extraordinary precision and extraordinary fragility. It spins a gas, uranium hexafluoride, at speeds approaching the sound barrier. The heavier isotope migrates outward. The lighter one concentrates near the center. Repeat this process across thousands of machines, linked in cascades, and you can gradually raise the concentration of fissile material from the 0.7% found in nature to the 90% required for a weapon. The machines that do this work are the program. Destroy them, and you destroy years of progress. Irreplaceable infrastructure assembled in secret, at enormous cost, in defiance of international law. They were what everyone wanted, and they were what no one could reach. By 2006, the question in Washington and Tel Aviv had stopped being whether Iran's nuclear program was a threat and had become something harder. What do you do about a threat you cannot physically touch? Airstrikes had been war-gamed repeatedly. The conclusions were consistent. The Natanz bunkers were built to survive conventional penetrating munitions. Even a successful strike would set the program back 2 years, maybe 3, and it would hand the Iranian government the most powerful domestic propaganda victory of the decade. So the question became a different one. Not how do you destroy the program, but how do you make it destroy itself? Inside the National Security Agency, a small team had been working on that question since the early years of the Bush administration. What they were building had no precedent. It wasn't spyware. It wasn't a data theft operation. It was a weapon designed to cross from the digital world into the physical one, to reach inside industrial machinery, inside the programmable logic controllers that told centrifuges how fast to spin and rewrite the instructions without anyone knowing they had changed. And while it did this, it would feed the human operators something else entirely. False readouts, pre-recorded normal data. Every alarm suppressed, every anomaly log clean. The machines would fail, and the men watching them would have no idea why. The project was called Olympic Games. It had been running in the background for years, evolving through multiple administrations, accumulating technical complexity that had required the resources of more than one nation. But the architecture of the operation was divided along a line that mattered. The NSA would build the weapon. Israel's Mossad would get it inside. That division was not bureaucratic. It reflected a genuine difference in what each service was equipped to do. The NSA had the cryptographic depth, the zero-day research infrastructure, the industrial control system expertise to build something of this complexity. But building the weapon and deploying it were two entirely different problems. Deploying it required human access to one of the most heavily guarded facilities on Earth. Access that no satellite, no signals intercept, and no remote intrusion could provide. Mossad's operational directorate had spent decades developing exactly the kind of human penetration networks that this problem required. The covert insertion of assets into hostile environments, the running of sources inside denial and deception-hardened targets. That was Mossad's domain. The Human Intelligence Service. The one that recruited people, ran them, and got them inside rooms where no electronic signal could reach. Working alongside them were partners whose contributions are less often named. Israel's Unit 8200 worked on technical development alongside NSA. German intelligence had contributed specifications on the Siemens industrial control systems used at Natanz. French intelligence had provided related data, and the Dutch had something specific that no one else had. They had a man who could get Mossad inside. The centrifuges at Natanz were not, strictly speaking, Iranian in origin. Their design traced back to the 1970s, to a Dutch centrifuge manufacturer, and to a Pakistani metallurgist named Abdul Qadir Khan, who had worked there and left with blueprints he was not authorized to copy. Those blueprints became Pakistan's nuclear program. Khan later sold copies to Libya and to Iran. This meant that Dutch intelligence, the AIVD, had spent decades tracking the procurement networks through which Iran built out Natanz. They knew the suppliers, they knew the contractors, they knew the technical specifications, and at some point, through a process that has never been made fully public, they had developed a source inside those networks. The AIVD had an asset, and Mossad needed him. But here is where the operation ran into the first of its walls. The CIA and Mossad approached the Dutch together, and the Dutch refused. The AIVD had its own calculation. Their source was producing intelligence. Not just about Natanz, but about Iran's broader procurement infrastructure, who was buying what, through which channels, across which borders. That network had taken years to develop, burning it on a single sabotage operation. An operation that, if discovered, would expose not just the asset but the Netherlands' direct participation in an act of covert warfare against a sovereign state was not a risk they were willing to accept on request. There were months of internal debate, pressure from Washington, pressure from Tel Aviv, quiet meetings at levels that don't appear in official records. The Dutch were being asked to hand a Mossad operation access to a source they had spent years building and protecting. Eventually, they agreed, but they agreed to something more than just access. The Stuxnet code, despite its extraordinary sophistication, had a problem the developers had been circling for 2 years. It had been built on intercepted data, satellite imagery, technical specifications. It had never been built on ground truth. The weapon needed to know exactly what was running inside Natanz. The specific firmware version on the specific Siemens controllers, the precise configuration of the centrifuge cascades, details that existed nowhere outside the facility itself. Reza could get those details, and under Mossad's direction, that is exactly what he was tasked to do. He was given a cover that held up to scrutiny, a commercial services company with legitimate contracts, enough paper history to explain his access, enough real work to make his visits unremarkable. He memorized the technical parameters. He went in, and he came back out with exactly what the developers needed. The weapon could now be finished. Calibrated, tested. What no one told Reza, what may not have been fully understood even by the people running him, was what it would actually do once deployed. He was carrying data out. Soon, he would be carrying something in. Here's the thing about a weapon that has never been used before. You can test it on replica systems. You can run it in a laboratory built to mirror the target. You can check its targeting logic, verify its dormancy conditions, confirm that it will only activate when it finds the exact configuration it was built for. You can do all of that. And you still don't know exactly what it will do inside a real facility, connected to real machines, moving through a real network that no laboratory has ever perfectly replicated. Olympic Games had been tested extensively. There had even been a demonstration, pieces of a destroyed test centrifuge laid out on a White House Situation Room conference table, physical proof that the concept worked. But Natanz wasn't a test, and the worm that Mossad was about to send inside through Reza was not a passive tool. It was alive, in the only sense that code can be alive. It would find, it would replicate, it would move. The question no one had fully answered, the question that would not be answered until it was too late to matter, was where exactly it would stop. Reza's second visit to Natanz was nothing like the first, not outwardly. Outwardly, everything was identical. The same checkpoint, the same credentials, the same guards who had stopped looking at his face a long time ago. The same walk across the same courtyard, the same elevator down into the underground facility. But the first visit had been reconnaissance. This was something else. The USB drive in his pocket that morning contained a program that its own developers had spent 3 years building and had never once deployed against a live target. It contained 4 zero-day exploits, 4 previously unknown vulnerabilities in Windows operating systems that no antivirus software on Earth was equipped to detect. It contained a rootkit that would hide the worm's presence from any diagnostic tool that tried to find it. It contained stolen digital certificates from a Taiwanese semiconductor firm, credentials that would tell the infected system this was legitimate, trusted, authorized software. It contained a fake data layer, a pre-recorded loop of normal operational readings that would play on a continuous feed to operator consoles while the real instructions ran underneath. And it contained a payload tested on centrifuge equipment that the US and Israel had quietly acquired to verify the attack would do exactly what it was designed to do. What Mossad had told Reza was still the same framing: surveillance, data collection, a passive tool. He plugged in the drive, 30 seconds, maybe less. Then he removed it, walked back through the facility, past the checkpoint, and drove home. Inside the Natanz network, nothing appeared to happen. That was by design. Stuxnet's first phase was entirely silent. The worm moved through the internal network, not aggressively, not at the kind of speed that would generate anomalous traffic patterns, but methodically, mapping architecture, checking configurations, verifying system types. It was looking for one specific thing: a computer connected to a Siemens S7315 or S7417 programmable logic controller, configured in a specific way, running a specific software version, managing a specific number of centrifuges arranged in a specific cascade pattern. Every computer it touched that didn't match those criteria, the worm checked, confirmed non-target, and went dormant on that machine, invisible, inert, until it found what it was looking for. The match came within days. The centrifuge control systems at Natanz met every criterion the worm had been programmed to verify: the cascade configuration, the controller type, the software version, all of it matched, down to the parameter-level detail that Reza had extracted on his first visit and handed back to Mossad's technical liaison. Stuxnet confirmed its target and began its second phase. The speed manipulation was incremental, not dramatic. The centrifuges that had been spinning at their standard operational frequency of 1064 Hz began receiving new instructions that passed through the same PLC interface the operators used, that looked identical to normal operational commands, that triggered no alarms because the alarm thresholds had been quietly adjusted in the same code update that delivered the attack. The machines accelerated. Not all at once, not in a way that would cause immediate catastrophic failure. The worm was patient. It pushed specific cascades to 1410 Hz and held them there for 15-minute intervals before returning them to normal. Then it dropped them far below operational speed for 50-minute intervals. The oscillation was the weapon. Aluminum rotors spinning at near supersonic speeds are not engineered for acceleration cycles. The stress accumulates in the material, microscopic deformations, invisible to any external inspection, building over days and weeks until the machine reaches a threshold and the failure becomes sudden. Iranian engineers began to see centrifuges failing. They began to see it at a rate that was unusual but not yet alarming. These machines did fail under normal operation. The failure rate was elevated, but not by an order of magnitude that demanded immediate explanation. They ordered replacements. They ran diagnostics that found nothing. They documented the failures and moved on. In Washington and Tel Aviv, the initial assessments were cautiously positive. Satellite imagery showed changes in the operational profile at Natanz. Signals intelligence was picking up internal Iranian communications about maintenance issues. The program that had been running silently for years was producing what appeared to be its first measurable results. At the operational level, the mood was careful, not celebratory. This had never been done before, and everyone involved understood that measuring the damage was only slightly easier than predicting it had been. But the early data looked like confirmation. Then something happened that the damage assessments hadn't accounted for. The worm left Natanz. Not by design, not through any failure in the targeting logic, that logic was working exactly as programmed. The problem was more fundamental than that. Stuxnet had been introduced through a human being who moved through the world. Reza had a laptop. The laptop connected at some point to a network outside the facility, a contractor network, a shared procurement system, something ordinary and operational that crossed the air gap boundary in the normal course of business. The worm replicated. That was what it was built to do, and it replicated onto that external connection. From there, it moved to the contractor's wider network. From that network, it moved to other contractors. From those contractors, it began spreading through the standard mechanisms of Windows file sharing, USB connections, network drives, all the ordinary infrastructure of business computing. By the summer of 2009, Stuxnet was on computers in companies with no connection to Iran's nuclear program. By the end of the year, it was on computers in India, in Indonesia, in Pakistan, in Azerbaijan. Approximately 100,000 machines worldwide were eventually infected. Every single one of them ran the targeting check. Every single one of them failed to match the Natanz configuration. Every single one of them stored the worm in a dormant state and did nothing. But they were infected, and infected machines, in the ordinary course of IT operations, get scanned. This is the moment where the operation's internal logic quietly collapsed. Not the attack itself. The attack was still running. The centrifuges were still failing. The damage was still accumulating. In that operational sense, Olympic Games was working. But Stuxnet was never just a cyber attack, it was a covert operation. And a covert operation has a second objective that is as important as the first one. It has to stay secret. The entire strategic architecture of what the US and Israel had built depended on deniability. If the attack was attributed, if Iran could point to the United States and Israel and say, "Definitively, you did this," then the diplomatic calculus changed entirely. The targeted sabotage of a sovereign nation's infrastructure is an act of war. Plausible deniability was not a secondary concern. It was a load-bearing wall in the entire structure. And now, there were 100,000 infected machines outside Iran. Inside the intelligence services running the operation, inside NSA, inside Mossad, the spread was known before the public discovery. Signals from the command and control infrastructure, the servers that Stuxnet periodically reported back to, were showing infection patterns that extended far beyond the intended target environment. The question being asked in very quiet rooms was a simple one. How long before someone looks closely at this? The worm had been designed with an expiration date, June 2012. The assumption had been that it would remain inside Natanz's closed network, do its damage, and eventually be overwritten or cleaned up in the normal course of the system maintenance. No one would ever see the full code. No one would be able to reverse engineer the targeting logic and understand what had been built. That assumption was now functionally dead. There was an abort discussion. The historical record on this is fragmentary, but multiple intelligence sources who later spoke to journalists described a period in 2009 and into 2010 where serious consideration was given to whether the operation should be terminated. Not reversed, the damage already done at Natanz could not be undone, but halted. New deployments stopped. The command and control infrastructure taken down. The argument for abort was straightforward. The worm was out in the world. It was spreading. Every day it remained active was another day closer to discovery. And discovery would not just expose the attack on Natanz. It would expose the methodology, the 0 days, the PLC targeting architecture, the data spoofing technique. Everything the NSA and Unit 8200 had spent years developing, everything Mossad had risked its human network to deliver, would become public knowledge. The argument against abort was also straightforward. The centrifuges were still failing. The damage was still accumulating. Pulling the operation now, before the full intended effect had been achieved, meant accepting a partial result at the cost of the same disclosure risk, because the worm that was already out there couldn't be recalled. The operation continued. No one went back to tell Reza. He had completed his role. The access he provided, the data he extracted, the device he carried inside on Mossad's behalf, all of it had served its purpose. Whether he knew that his entry point had been the origin of an infection now spreading across a dozen countries is not part of any record that has been made public. What is part of the record is that the window through which the operation had functioned, the contractor network, the procurement access, the cover company, was a finite resource. Every day the worm remained active, and undiscovered was a day closer to the moment when Iranian counterintelligence would start working backward through access logs. The operation had produced damage, had real, measurable damage. It had also produced something no one had planned for. A weapon loose in the world, on 100,000 machines, that would eventually be found by someone who had nothing to do with Iran, nothing to do with nuclear programs, and nothing to do with the question of whether Natanz should be stopped. Someone who would simply look at it, understand what they were looking at, and then publish everything. The failure reports from Natanz had been accumulating for months before anyone in Tehran used the word sabotage. That delay was not stupidity. It was the worm working exactly as intended. When machines fail in ways that look like ordinary mechanical failure, the human mind reaches for ordinary explanations first. The engineers at Natanz were experienced. They ran diagnostics. They cross-referenced failure logs. They ordered component analysis on the destroyed rotors. Everything they found pointed inward, to manufacturing tolerances, to material fatigue, to the ordinary stress of running precision machinery at the edge of its operational envelope. The monitoring systems confirmed it. The cascade readouts confirmed it. The worm confirmed it, because the worm was writing the readouts. By late 2009, the failure rate had crossed a threshold that maintenance cycles could no longer absorb. A centrifuge that fails in a cascade does not fail quietly. The rotor, spinning at nearly the speed of sound, doesn't simply stop. It contacts the outer casing. It fragments. It can damage adjacent machines in the same hall. The engineers at Natanz were now managing cascading mechanical failures in the most literal sense, one machine's destruction creating vibration and pressure anomalies that accelerated stress in the units beside it. They pulled entire cascade halls offline. They ran inspections that found nothing wrong with machines that hadn't yet failed. They put the inspected machines back into service. The worm was waiting on every one of them. What the engineers couldn't see, and what the operators watching the consoles couldn't see, was that the readouts they were trusting had been compromised at the source. The PLC layer sits between the physical machinery and the human interface. It is the translator. What the centrifuge is doing physically and what the operator sees on screen are only the same thing if the PLC is reporting honestly. Stuxnet had inserted itself into that translation layer months ago. The pre-recorded normal data playing on the consoles was not a crude replacement. It was pulled from the facility's own operational history, actual readings from periods of normal function, looped and presented in a sequence that mimicked normal variation. Pressure fluctuations that looked like routine thermal changes. Speed readings that showed the minor oscillations any centrifuge produces. The kind of data that experienced engineers would look at and find unremarkable. The engineers found it unremarkable. In Washington, the damage assessments were becoming more confident. Imagery analysis was tracking changes in the operational profile at Natanz with enough consistency to support a conclusion the program was losing ground. Not catastrophically, not visibly, but measurably. The centrifuge count was declining faster than it should have been. The enrichment output numbers being reported by Iranian officials to international inspectors showed a gap between installed capacity and actual production that couldn't be explained by declared maintenance alone. The weapon was working. And then the teams running Olympic Games made an assumption. The assumption was about containment. The spread of Stuxnet outside Natanz was known. The infection of external contractor networks had been detected through command and control monitoring as early as mid-2009. The 100,000 machines outside Iran were a known quantity. Dormant infections on non-target systems, none of them matching the Natanz configuration, none of them executing the payload. The operational assessment was that this was manageable. The targeting logic was sound. The worm wasn't doing anything on those machines, and because it wasn't doing anything, there was a working assumption that it wasn't generating the kind of anomalous behavior that would attract serious scrutiny. The assumption was that dormant meant invisible. It was wrong. In June 2010, a support call came into a small antivirus company in Belarus called Virus Blockade. The client was in Iran, not at Natanz, not connected to the nuclear program in any way. An ordinary commercial office environment experiencing mysterious system instability, computers rebooting unexpectedly, fresh operating system installations becoming corrupted within hours of deployment. The analyst who took the call was named Sergei Ulasin. He was at a wedding when his phone rang. He spent the evening working the problem remotely, talking his Iranian contact through diagnostic steps, trying to isolate what was causing the instability. He was thinking in terms of ordinary malware. A criminal piece of code, probably financially motivated, probably built on a known framework. What he found was nothing like that. The first anomaly was the sheer number of 0 days. Ulasin and his team had seen 0-day exploits before. One per piece of malware was typical for sophisticated criminal operations. Nation-state tools sometimes used 2. What was in the code they were analyzing used 4 previously unknown Windows vulnerabilities, all active simultaneously, all serving different functions in the propagation chain. That wasn't criminal malware. Criminal actors don't burn 4 0 days on a single deployment. 0 days are finite, expensive, and once published, they're patched within weeks. You don't spend that kind of resource unless the target justifies it. The second anomaly was the stolen certificates. The code was signing itself with legitimate credentials from a real Taiwanese semiconductor company. Someone had physically compromised that company's signing infrastructure. This was not a remote intrusion. This was a physical operation nested inside a cyber operation. Ulasin called his colleagues back in from the weekend. When Virus Blockade published their initial findings, the response from the global security community was not gradual. It was immediate. Every major cybersecurity firm on the planet began pulling and analyzing samples within days. Kaspersky, Symantec, F-Secure. The researchers working these samples understood within the first week that they were looking at something that had no precedent in the documented history of malware. The code was enormous, 0.5 megabyte, 50 times the size of a sophisticated criminal worm. It had multiple layers of encryption. It had a peer-to-peer update mechanism that allowed infected machines to share updated versions with each other without contacting any external server. It had a kill switch, a counter that would cause the worm to delete itself after a specified number of replications, designed to limit uncontrolled spread. That kill switch had not worked as intended. Inside the operational teams running Olympic Games, inside NSA, inside Mossad, the virus blockade publication triggered the discussion that the earlier aborti consideration had deferred. The worm was now public. Not fully understood yet, the full technical analysis would take months, but visible. Identified, named. Stuxnet, a label stitched together from strings found in the code. The question was no longer whether discovery was coming. Discovery had arrived. The new question was whether continued operation made any strategic sense, or whether running the worm for additional weeks while the entire global security community reverse-engineered its architecture was simply accelerating the exposure of methods and capabilities that, once public, could never be recalled. There was a strong argument for immediate shutdown. The shutdown didn't happen. The decision, and it was a decision, not an oversight, was to keep the operation running. The justification, as best as can be reconstructed from what intelligence sources later described, was a judgment about timing. The security researchers had the code. They would eventually understand the Siemens PLC targeting. But understanding the code was not the same as understanding where it had come from and what it had done. Full attribution would take time. And in that window of time, the centrifuges at Natanz were still failing. This was the incorrect assumption playing out in real time. The belief was that attribution lag would provide operational cover, that by the time anyone connected Stuxnet conclusively to Natanz, the damage would be complete, and the weapon would have expired on its programmed schedule. What the assessment underweighted was the speed of the security research community when given a problem of this visibility and this complexity. By September 2010, Symantec had published a detailed technical analysis that identified the Siemens S7315 and S7417 controllers as the worm's specific targets. They had found the centrifuge speed manipulation code. They had reconstructed the data spoofing layer. They had mapped the kill switch logic. They had not yet confirmed Natanz as the target. But they had published enough that anyone inside Iran with access to the Natanz facility's technical specifications could make that connection themselves. Iranian President Ahmadinejad confirmed publicly that centrifuges had been affected by malware. The statement was brief, almost casual. It confirmed nothing about the scale of the damage. The internal assessment in Tehran was not casual. And here is the moment that looked briefly like resolution. The worm had been discovered. The attack had been attributed, at least internally, to the United States and Israel. The Iranians were now working to clean infected systems and replace destroyed centrifuges. The operation, in its active phase, was functionally over. For a brief period in late 2010, intelligence assessments out of Washington and Tel Aviv suggested the program had been set back by somewhere between 2 and 5 years. Enrichment capacity had dropped measurably. The cascade counts had not recovered. The replacement centrifuges would take time to procure and install. It looked like the damage had held. By the time the active phase of Olympic Games ended, Iranian engineers had documented the destruction of approximately 1,000 IR-1 centrifuges, roughly 1/5 of the installed cascade capacity at Natanz. The machines Mossad's operation had reached, through a single USB drive carried by a single man through a single checkpoint, had been methodically destroyed from the inside without a shot fired, without an aircraft crossing Iranian airspace, without a single Iranian engineer understanding what had killed the machines they were standing next to. It hadn't held, but for a moment it looked like it had. The first consequence arrived before the last centrifuge failed. That timing matters, because it means the operation was already producing outcomes its architects hadn't planned for while it was still running. The fallout wasn't a postscript, it was concurrent. It was happening in parallel with the damage assessments and the positive intelligence reports, quietly accumulating in the background while the weapons designers were still measuring what they'd built. Iranian counterintelligence began working backward almost immediately after Ahmadinejad's confirmation. Not from the code, The code told them what had been done to their systems, not how it got there. They approached it the way any competent counterintelligence service approaches a penetration, from the access end. Who had been inside the facility? Who had worked on the control systems? Who had visited through contractor channels in the relevant window? The procurement networks that had served as Reza's cover were suddenly under a different kind of scrutiny. The front company that had given him legitimate access, the contractor relationships that had made his visits unremarkable, the commercial infrastructure that the US and Israel had spent time and resources building as a cover vehicle, all of it was now being reviewed by people whose only job was to find the seam. Reza's name has never appeared in any official account. What the record contains, in fragments across multiple intelligence sources who later spoke to journalists, is a description of what happened to the network he was part of. The procurement channel collapsed. Contacts who had been operational for years went quiet. The AIVD's visibility into Iran's centrifuge acquisition infrastructure, the intelligence product that had made the Dutch asset so valuable in the first place, the product that the AIVD had weighed against the CIA and Mossad's request for years before agreeing, was gone. The thing the Dutch had been most afraid of losing, they lost. Whether Reza survived the exposure of that network is not something any public record confirms or denies. He exists in the documented history of Stuxnet as a function, the access mechanism, and then he doesn't exist at all. That absence is its own kind of answer. The second immediate consequence was the global one, and it moved faster than any of the operational assessments had projected. By November 2010, the full Symantec technical paper had been circulated widely enough that the security community had effectively open-sourced the most sophisticated cyber weapon ever built. Not intentionally, not maliciously. Through the ordinary process of professional analysis and publication, that is the security industry's standard response to a new threat. The zero-day exploits were now documented. The PLC targeting methodology was now documented. The data spoofing architecture, the technique of intercepting industrial control readouts and replacing them with pre-recorded normal data while the actual machinery is being attacked, was now documented. Every piece of tradecraft that had taken years to develop, that Mossad had risked its human network to deploy, that NSA and Unit 8200 had spent years perfecting, all of it was now in a white paper that anyone could download. Iran replaced the centrifuges. This is the sentence that the optimistic 2010 assessments had not fully prepared for, even though it was always the inevitable outcome of a program that had not been physically destroyed, only degraded. The IR-1 machines that Stuxnet had targeted were not the future of the program. They were already considered outdated by the Iranian engineers who ran them. The second and third generation centrifuges, IR-2 meters, IR-4, IR-6, that had been in parallel development used different control architectures, different PLC configurations, different operational parameters. Stuxnet had been built for a specific target at a specific moment. The target rebuilt itself into something the weapon could no longer reach. By 2012, the cascade counts at Natanz had recovered. By 2013, Iran had installed advanced centrifuges at a second facility, Fordow, buried even deeper underground than Natanz, a facility hardened specifically against the kind of access operation that had made Olympic Games possible. The 2 to 5 year setback assessment, which had seemed conservative at the time it was made, turned out to be optimistic. The 2015 nuclear deal, the Joint Comprehensive Plan of Action, froze the program at specific thresholds. It was presented as a diplomatic achievement, and in its own terms it was. But the conditions that made Iran willing to negotiate were never solely the result of Stuxnet. Sanctions, oil price pressure, internal economic strain, and years of diplomatic architecture all contributed. The direct line drawn by some analysts between the centrifuge sabotage and the eventual agreement is cleaner in retrospect than the actual causality supports. When the United States withdrew from the agreement in 2018, Iran announced it would resume enrichment above the deal's limits. It did. By 2023, Iranian uranium enrichment at some facilities had reached purity levels that international inspectors described as approaching weapons grade. The infrastructure that Stuxnet had damaged had not only been repaired. In the years of reconstruction, it had been expanded and hardened beyond what existed in 2009. The program that Olympic Games was designed to stop was larger when the long-term consequences were being assessed than it had been when Mossad first sent Reza through the gates at Natanz. The second long-term consequence was the one no pre-operation assessment had seriously modeled. Stuxnet established that attacks on physical infrastructure through cyber means were not theoretical. They were demonstrated, documented, and achievable by any actor with sufficient resources and access. The question the security community had debated in white papers for a decade, can a cyber attack cause real-world physical destruction, had been answered in public with a detailed technical explanation of exactly how. In the years that followed, attacks on industrial infrastructure appeared with a frequency that had no precedent. A Ukrainian power grid went dark in 2015 and again in 2016 through attacks bearing structural similarities to Stuxnet's methodology. A Saudi oil facility's safety systems were compromised in 2017 in an attack designed to cause physical explosions, one that failed only because of an error in the attacker's code. A Florida water treatment facility in 2021 had its chemical levels remotely manipulated through its own control systems. None of these were Stuxnet, but all of them were downstream of it, downstream of the proof of concept, downstream of the published analysis, downstream of the decision to build and deploy a weapon whose architecture, once exposed, became a framework for everyone who came after. The US and Israel had demonstrated the capability. They had also extended it by deploying it in a way that couldn't be kept secret to every state actor and sophisticated non-state actor willing to invest in the methodology. The Dutch intelligence service lost its procurement network. That loss was not abstract. Networks like that are built over years, through patient cultivation of sources who take real personal risk. They are not rebuilt quickly. The intelligence that the AIVD had used to track Iran's centrifuge acquisition, the visibility into which components were being bought through which channels, the early warning that had made Western sanctions enforcement more precise, was degraded in ways that persisted long after the Stuxnet story became public knowledge. The cost the Dutch had most feared when they initially refused the CIA and Mossad's request was exactly the cost they incurred. The NSA and Unit 8200 lost something less tangible but arguably more significant. They lost 4 0 days. Zero-day vulnerabilities, unknown flaws in widely used software, are intelligence assets in the most literal sense. They are discovered through painstaking research, protected carefully, and deployed selectively because once deployed and identified, they are patched and they are gone. The 4 Windows 0 days in Stuxnet were patched by Microsoft within months of the public discovery. Years of research, expended in a single operation, now available to every attacker as documented methodology. Mossad lost the network it had built to run Reza. Not just the front company, not just the contractor cover, the deeper procurement intelligence architecture that the Dutch asset had enabled, the visibility into how Iran was rebuilding its centrifuge capacity, which sanctions were holding, and which were being circumvented, collapsed when the counterintelligence review began. The human access that had made the operation possible was precisely what the operation destroyed. Reza, in the historical record, is a function and then an absence. He carried something into a facility on behalf of people who did not fully explain what it was. He did this, presumably, because he had reasons of his own that no journalist or intelligence source has ever documented. Ideology, money, coercion, belief, the record doesn't say. What the record does say, in the shape of its own silence, is that the operation requiring his participation did not protect him from its consequences. The network Mossad had built around him collapsed under scrutiny. The cover that had made him unremarkable was the first thing Iranian counterintelligence would have pulled at. That is not an unusual outcome for people who occupy his role in operations like this one. It is, however, worth naming. Because the history of what Stuxnet was, and what it did, tends to run at the level of governments, programs, and capabilities. The human cost gets absorbed into the word asset and filed away. The centrifuges at Natanz have been rebuilt. The code that destroyed them has been studied, adapted, and in some form redeployed by actors who had no role in writing it. The man who carried it in has no confirmed fate in any public record. If that feels unresolved, it's because it is. Operations like this don't end, they change shape. If this operation made you think differently about how power actually moves in the world, quietly, through people whose names never appear in any official account, then you're in the right place. Subscribe to Hidden Ops. New operation every week.